Thank you for coming to our session on differential governance. My name is Anant Mistry. I'm the Chief AI Officer for GTS, Global Technology Solutions. And I'm joined by Dr. Atif here. Dr. Atif, if you would mind introducing yourself, please.
Dr. Atif Mohammad, the Chief Information Security Officer and the Generative AI Head for the Center of Excellence we have established at Global Technology Solutions. I'm also a Professor of Artificial Intelligence at UNC Charlotte, University of Cumberland, Kentucky, Texas Wesleyan University in Fort Worth, Texas.
Now, I did notice that Dr. Atif did walk around and promise that you would not be bored. He lied. You may be bored.
With his speech.
Yeah, just put your hand up, just say that you're about to fall asleep. You could always stop by our table. Excuse me, sir. But no, he says stop by our table. You can actually pick up a free chai, and that'll keep you awake. But don't do it during this. That would be kind of rude. So, but again, my name is Anant Mistry. We're here to go and present differential governance. Feel free to stop me if you have any questions. There'll be time at the end for questions as well. I know we only have, about 20-ish minutes left, so I will get pressing on. So, our agenda today. Sorry, was there a question? No? Okay.
Carry on.
So today, our agenda is we're going to do an introduction, give you a quick idea of who GTS is. We'll talk about differential privacy and differential governance. We'll go into a deeper dive on what differential governance is, and then have time for questions. So GTS, we're an AI ML company. We have a great prowess in contact center, generative AI-powered contact center. We have a great presence in document AI and intelligent document processing. So when you're processing corpuses of information, basically unstructured data, you're able to process them at scale. You will have seen this. This is our trifold flyer. You feel free to, you don't need to take pictures of this. We actually have the flyers at our table. But basically, it goes to show all the three major spaces that we play in. And so we do a Gen AI and Gen AI workshop. And that's actually in numerous different spots so that we can actually address different parts of your organization, whether it be the upper tier, the lower tier, or in between, middle management, and be able to give you best practices for dealing with generative AI, and then also the differential governance model. In the center there, you see document AI, so for intelligent document processing. So this is our solution in whichever cloud space you want to be able to be in, and to be able to process your documents at scale. You're able to figure out what your documents contain, what you want to do with them, and then where you want to store them. And then the last one is the Omni Assistant AI. So the Omni Assistant AI is a chatbot powered by generative AI. Now, this whole space, we play in both the contact center space in Google as well as AWS. We do have demos of this as well as implementations. So this is who we are. We do other AI ML projects as well, but these are our core competencies. Any questions from anyone about this? Okay. So as you see, we cover a wide range of industries. Our footprint is ever expanding, and we're also growing as a company as a result. So let's start. Actually, before I start, how many people have heard of differential privacy? Okay, good. Anyone that would have their hands up would care to explain what they understand by differential privacy? Anyone?
I can tell you about how we do it with geospatial, which is my
Sure.
industry.
Please.
So in geospatial, which is my industry, we oftentimes will obfuscate data to make it significantly or statistically still significant for doing analytics down the road, to where we're moving points by different ways of obfuscation. This allows us to broadly share our data across industry and publicly for people to do research on without actually giving away any crucial information.
Okay. And so what information what IP are you protecting through that?
Well, with geospatial, a lot of times it's locational intelligence data. So rooftop analytics will take the data and will move those points around to where it won't actually be sitting on people's homes or driveways or cars or whatever it is that we're looking at.
Yeah, great. Thank you so much for sharing. And that's a fantastic use case. So, and if I was to kind of bring it at a much higher level, you're essentially introducing noise, right? A calculated noise, so that statistically it's still significant, but it's not accurate enough to be able to go and locate a particular rooftop, as in your example. Yeah? Okay, great. So, and effectively that's what differential privacy is. So this is the citation from Wikipedia. I could read this out. I could even read it out in a monotone fashion and put you all to sleep, but I'm not going to do that. But basically, it's about saying the same thing, right? Is hiding specific information, especially if that demographic happens to be one. So think of it of, let's just say a patient, right? And a patient has a particular affliction, but there's only one in a town. You don't want to be able to do a specific set of queries to be able to isolate who that person is or where that person is, right? So you want it, but you still want to be able to do AI ML. You still want this data set to be useful, but you want to be able to do it with a protective layer. And essentially, that's what differential privacy comes up into. Differential privacy is interesting. It's been out there for quite a while, and it's actually expanded. Its footprint has actually expanded over time. It started out with being kind of algorithmic controls, where you actually have a model and you have an encrypted key, and you're able to work with a model with that encrypted data and to be able to do like classification or regression type operations, algorithms. And the problem is that A, it's computationally intensive, and B, it doesn't, there are very few models out there that can actually work with encrypted data. So basically, if I'm a vendor, I host a model, and this model is for doing classification, let's just say, okay? Well, and I have a customer, and the customer doesn't want to send me unencrypted data. They can encrypt it, send me the encrypted data to my model. Because it's encrypted, I can't decrypt it, but the answers are going to come back the same, whatever that same looks like. They will get the results. They have the key to be able to decrypt that data. So at that point, I supplied the model, and the operation got performed as a service, but I don't get to see it, and the customer was able to do that securely. It's a great model, and it sounds great. It's impractical. It doesn't work in the marketplace. They have to do it. We have to do it through other mechanisms. Introducing noise is one mechanism of being able to do it, but those are the challenges that you have with differential privacy. Any questions about differential privacy before? I have an expert on quantum computing right next to me.
Test. Okay, there you go. So you're absolutely correct. It's either 0 or 1 in binary, but it can be 0, it can be 1 at the same time. The Schrodinger's case, if you remember what I mean. If you don't, Google it. I'm not going to go into that details because that's inhumane as per the current atmosphere around us. So just for the sake of understanding, the world has gone above 0 and 1. There is a unknown direction that where we are heading. The great Donald Rumsfeld, why I said great, it was a philosopher also, who said known knowns, known unknowns, unknown knowns, and unknown unknowns. What you just said, sir, is unknown unknown, however, that exists in quantum computing. And obviously, you're right, there is no cryptic thing will remain the day will hit the quantum computing algorithms running around on top of the SDG or the stochastic gradient descent, SGD, technically. And once they are going to go in that, that's where differential governance kicks in. And you actually nailed it asking this, because the differential governance that we have proposed, we just got published in an IEEE, and that involves the quantum calculations. We cannot do it because we don't have the standard quantum computer available. However, when we start applying it at sort of a grid computing using the cloud, we can mimic it. So yes, back to Anant.
Thank you for that, Dr. Atif. Did that answer your question? Yeah? So let's shift to differential governance.
So thank you, Anant, for transiting this good transition. So I'm working on cybersecurity for quite a while. Being a PhD in cybersecurity, when I got a chance to do a second doctorate in artificial intelligence, that took me on a route where no man had gone before, as per my understanding, the Star Trek phenomena. I started looking at annualized rate of occurrences of the threats which we are facing in our everyday life. It doesn't matter which industry it is. We went to the exposure factor, analyzed loss expectancy, single loss expectancy. So differential privacy is pretty much the single loss expectancy where we can figure out who's who. And a person like me can easily find that information if the noise is even there. So the idea is applying differential governance by finding out the best possible values to include as a way as not 0 or 1, but the third dimension, the unknown unknown, and that's where it kicks in the differential governance stochastic gradient descent learning. A simple example, who of you like cookies? Raise your hand. Oh, quite a few people. So if I ask you to go make a cookie, and you're not the only one, and you're 300 students of mine, and I ask all 300 of you to go find your own baking class where the cookies are being taught to bake, you will bake it. Then you will actually share with 299 of your peers those cookies and take everyone's opinion, absolutely anonymized. You still know that these are your peers, but you don't know who said, 1, it's the worst cookie I have ever eaten. 10, it's the best cookie I have ever eaten. And then you find out the plausibility by taking up 51%, it's the best cookie you have done. But 51 is not a good percentage. You'll go and tweak the same baking formula and rebake cookies by having a little bit alteration in the ingredients. More sugar, less flour, and then you do it again, the same experiment goes on, and you do the same thing, and all 300 students of mine are baking cookies and everybody's tasting it. The tasting bud of everyone is different. That's a human experience. And differential governance is you are governing by your own baked cookie, learning as a human, what is the end result? In the end of the day, you might find a certain percentage acceptable. 73% said, this is the best cookie you got. That came out of those experiments that you have done. Exact same thing I can replicate. You are one person leading a 10 skiers team to Boulder, Colorado, and you want to win. What you have to go and do about it, you will figure out where the slope is pretty steep, where there is a little bit flatness in the skier will find, where the skier would be going down fast, or where the skier would be slowing down and then going down fast. If you do that mathematics, your skiers even go on to compete, it's a highly likely possibility that you will be the one bringing in the winner team out of the skiing championship. That is an example of the stochastic, which is random, gradient descent, which is going down the hill. So people might think going down the hill means it's a bad idea. No, it's a great idea if you're doing a skiing competition. So when I looked at all of these, I went in and I took a randomized approach in this, and I added a little bit qubit calculation, which is the quantum bit. And I said, okay, let me apply it in a binary arena using the third as potential plausible answer that I am getting on some of the data that I have. And that's where it kicked in from the access control lists, which are pretty old way to work with. Applying the policies of cybersecurity, if you're in the HIPAA controlled environment, then do you have FHIR implemented? Are you making sure that PHI has been compliant? And simultaneously, the person might be living here from UK, how you're going to face for him or her or them when they go back, and the information needs to be transmitted back to the national NHS rather than the HHS. So that's a human thing that came out, and that allowed me to conduct research on this area, and then I proposed, and obviously Anant is a very, very nice gentleman who reviewed the work. We have Tony Colombo, I call him Detective Colombo. He read that paper as an observer, and Luke read it from GTS, and we have wonderful Jess. She's our English major. Since English is my 5th language, so I take expert advice from Jess, and then we sent it for the publication. It was published in the first go in an IEEE conference, which is like 30% in the top. And so that's why I decided to bring this to this audience with the help of Anant, because we have been looking at these to provide our specifically healthcare folks, because I had dealt with once 5 million plus population of Medicare, Medicaid. Extensively, we had a transition came out from a little bit older, 5-year older chatbot with the standard rule-based on the back-end knowledge. And then we converted it by using the generative AI. So ChatGPT is not the only one on earth. I wrote 7 LLMs since 2019 by myself, because I cannot afford clusters. I have a very small cluster of 9 blades in my basement, which I try and run my LLMs with few millions of tokens rather than billions. I'm not talking about Megatron or Llama, which are coming out, or Palm 2. But the idea of natural language processing to natural language understanding to natural language generation, which is also known as, everybody says RAG, 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 the retrieval augmented generation. That is nothing but I eat, what is the potential next word? All of us can think, like Marquis might think cookies. Pranav might think, taco. Luke might think burger. I might think, food. And food is a generic most. Back to Anand.
Dr. Atif, I think we've got 1 more minute left.
Oh, Sorry.
Yes. No, this is good.
So back to Anant.
Actually, if you,
Okay, you read this on your own time. I'm a professor, this is your assignment.